after revising this lesson, you are expected to define the term argument and identify the validity of a given argument. So let's see what an argument means. Argument is an assertion that a given set of statements, P1, P2 up to Pn, we call this hypothesis or premises, yield another statement Q, we call conclusion. So argument is an assertion that gives a set of statements yielding another statement, we call that conclusion. Here an argument form can be denoted by in this form: P1, P2 up to Pn, these are premises yielding a conclusion. Or it can be written in this form: P1, P2 up to Pn, these premises yielding a conclusion Q. This is an argument form. Now, an argument form P1, P2 up to Pn yielding a conclusion Q, these are premises yielding a conclusion Q, is said to be valid if Q is true whenever all the premises are true. Otherwise, it is invalid. So, to test whether a given argument is valid or invalid, first you assume the premises, all the premises to be true. And then, if you arrive at if a conclusion is true, so in that case, the argument becomes valid. Otherwise, it is invalid. So let's see example for this. Look this one. Here it says, investigate the validity of the following argument. P implies Q will be Q here. The conclusion is Q. To test or to check whether this argument is valid or not, what you do is assume all the premises are true. So 1, P is true because it is premise. Because premise. One. Second, you have to also assume P implies Q to be true because you have to assume all the premises to be true. So we assume this to be true. This also, P implies Q is also it is true with the same reason. So from 1 and 2, you can see that this whole statement it is true. And P is also true here. So true implies Q gives you true. So this Q must be true. If it is false, true implies false, the result becomes false. It can't give you true. Therefore, we have found P to be true. True implies something is true, so Q must be true. Therefore, here from 1 and 2, Q is true. Q is this true. So what's our conclusion? Our conclusion is Q. So we arrived that Q is true. Therefore, assuming the premises to be true, the conclusion becomes true. Therefore, this argument form is valid. Therefore, here, P implies Q and Q. This it is valid. It is valid. Okay. By the way, alternatively, you can check the truth value using truth table for this statement. Using truth table. We have two statements here, P and Q. So we have to the power of 2 possible combination of true and false. So here, let's take truth table. Here we have P, Q, and P implies Q. Let's prepare a table for this. P implies Q and Q. So since we have 4 possible combination of true and false, let's take 2 truths and 2 false here, and true, false, true, and false. Okay. Now, true implies true. It is true. Implies is it is false whenever the first statement is true and second is false. Otherwise, it is true. True implies true. True implies false. It is false. And false implies true. It is true. And false implies false. It is true. Now, what are our premises? Our premise is these two. The premises are P and P implies Q. So we assume this to be true. Therefore, P is true and P implies Q is true. This is the first row. And the conclusion is this Q. The conclusion Q is true. Okay, let's check all possible combinations. Here, is there any other possible combination where the premise is true? I think we don't have the other part. P implies Q is true here. P is false. P implies Q, true is here, P is false. Therefore, for the premises P implies Q true and P true, for these premises, the conclusion is it is the conclusion Q is true. Therefore, it is valid. The statement is valid. So we can use a truth table, by the way. Let's see this one. Investigate the validity of this argument. Here it says, negation of P implies Q. Q gives the conclusion P. So, first, you assume the premises to be true. 1. Let's start from this single statement Q. Q is true because it is premise. It's a premise. Okay. Now, second, negation of P implies Q. This also true with the same reason. It's a premise. Q, negation of P implies Q. Both are premise. So we assume this to be true. Now, here we know that Q is true. Negation of P implies Q also true. So what will be the value of this negation of P? If the negation of P is true, true implies true, it gives you true. It can be true. If negation of P is false, false implies true, it gives you true. So here, negation of P is true, or it can also be false. Therefore here, P is, negation of P is true means P is this false or true. Therefore, our conclusion is P. P is not true only, it can be also false. So, this statement is invalid because assuming the premises to be true, the conclusion must be exactly true, otherwise it's not valid. But here, the conclusion P is not exactly true. It may be also false. Because of this statement is invalid. Therefore, here, negation of P implies Q, comma, Q gives you P. This is invalid. Invalid. Okay, you can use table also to test whether it is valid or invalid. We have two statements, P and Q. So we have true, true, false, false, here true, false, true, false. Negation of P implies Q. Let me have negation of P here. Negation of P, it is false here. Negation of true. Negation of true is false here. Negation of false, true. Again true here. Okay. Next, let's find negation of P implies Q. Negation of P implies Q. Negation of P implies Q. Negation of P implies Q, here it is false implies true, it is true. False implies false, it is true. True implies true, it is true. But here true implies false, it is false. Okay. Now, what are our premises? Negation of P implies Q. We have one premise here. And the other one is this Q. We have another premise. So, let's check the values where both the premises are true. Here, both are true on the first row. On second row, both are not true. On third row, both are true here. On the other, there is no. So, we check the first and the third row. Whenever the premises are true, what's our conclusion here? Our conclusion is P. Our conclusion is this column. Whenever the premises are true, the conclusion, it is true here. Whenever the premises are true, it's not true here. Because of this row, this statement is invalid. This statement is valid. Therefore, the argument negation of P implies Q. Q gives you P is invalid. Now let's continue to the other part. Okay, let's have this. If the rain doesn't come, then the crops are ruined and the people will starve. The crops are not ruined or the people will not starve. Therefore, the rain comes. Check the validity of this argument. Okay, to check this argument, its validity, we need to convert this into symbolic representation. So, let's put a symbol for a given statement. If the rain does not come, let's assume P is the statement if the rain comes. Let's assume P to be the rain comes. Okay, the crops are ruined. Another statement. Let's assume Q to be the crops are ruined. The crops are ruined. The crops are ruined. Okay, what else? We have also another third statement here. The people will starve. The people will starve. R. The people will starve. Okay, now the crops are in the same statement. The people will not starve, therefore the rain comes. So we have given a symbol for each statement there. So let's convert this into an argument form. Here the first says, if the rain does not come, the crops are ruined. If then statement. If then it is P plus Q form. If the rain does not come, the rain comes is P, does not come, it's negation of P. If the rain does not come, then the crops are ruined. The crops are ruined, it's Q. Negation of P implies Q. The crops are ruined and the people will starve. Therefore, here the crops are ruined as this Q, and the people will starve. The people will starve is R, Q and R. Okay, this is one premise. The second one, the crops are not ruined. The crops are not ruined is Q, it's negation of Q, are not. It's negation of Q, or the people will not starve. The people will not starve. R is the people will starve, so the people will not starve is negation of R. So the people will not starve is this negation of R. So therefore the rain comes. Therefore is a conclusion. Therefore the rain comes. The rain comes is P. Therefore the rain comes. Okay, this is argument 4. Now to find it is to test its validity. Let's see this one. Let's use one property, De Morgan's law. Negation of P or negation of Q can be written in this form. You can take negation as a common and you convert or into and. I can write in this form. Therefore, here let me write this in another form. This negation of P implies Q and R. Let me write this one in this form. Negation of Q, we have this argument form. To check this validity, we assume the premise to be true. So let's take from this one, negation of Q and R. Negation of Q and R is this. It is true because it is premise. Because this premise. Okay. Second, from this you'll have this one. Q and R is this is false. Negation of Q and R true means this statement, this part is this false. Q and R is false. Okay. Second, the other premise, this one. Negation of P implies Q and R. Negation of P implies Q and R. Q and R. This also is true. With the same reason, it's premise. Okay. So here, look, the whole this statement it is true, but this one is false from one. Q and R is false. Q and R is false here. This one is false. So this statement implies false gives you true. So from this, negation of P must be false. If it is true, it doesn't satisfy this one. True implies false. So this one is true. The whole statement is true. This part is it is false. This negation of P must be true from these two, from this one, from 1 and 2, from 1 and 2. Negation of P must be false. False implies false gives you this one. Otherwise, it can't. So negation of P is false from 1 and 2. So this implies negation of P false means P is true. So what's our conclusion? Our conclusion here it is P. So the conclusion it is P is true. Therefore, assuming the premise true, we arrive at the conclusion to be true. Therefore, this statement is it is valid. It is valid. It is. Please students, try to check the validity of this argument using a truth table. So let's proceed to the other part. Rules of inference. Here, the first rules, these rules are important to test the validity of some complex arguments. So here, if P is true, this is a premise, and P implies Q is true, both are true, so Q must be true. If P is true, this must be true, the whole statement is true. So this rule of inference, we call this, its name is mode exponents. Here, negation of Q, true, P implies Q is true, these are premises. So since negation of Q is true, Q is false. Q is false here. So P must be false so that this proposition to be true. False implies false gives you true. So P must be false. So it's negation. P is true is a conclusion. Is true, therefore this is also a valid argument. This is a valid. Therefore here we call this, it is a principle of syllogism. If P implies Q and Q implies R, then P implies R is valid. So we call this a principle of syllogism. By the way, you can test the validity of each using truth table or by formal proof form. So let's see this one, a principle of adjunction. If P, these are premises, P true, Q true, therefore P and Q is also true. It's valid, this one. Here, if P is true, therefore whatever Q is, P or Q is true. It's valid. We call this principle of adjunction. Now here, principle of detachment. Say here, if P and Q is true, both P and Q must be truths. That's it. We call this a principle of detachment. The other rule of inference here, negation of P, true. Negation of P is true means P is false. Here P is false. False or Q must be true to be this statement is true. Therefore, the conclusion is Q. It is true. It's valid. So we call this modus tollendo ponens. Okay. The other one, principle of equivalence. If P is equivalent to Q, or if P by implies Q, if this statement is true, P is true. If P is true, Q must be true so that the whole statement or P by implies Q is true. Therefore, we have P true here, the whole statement true. Therefore, Q must be true. The conclusion is Q. Here, principle of conditioning. If P, here, P is true, P is true. At the conclusion, P is true. So Q implies P is true, whatever the value of Q is. If it is true, true implies true, gives you true. If it's false, false implies true, also gives you true. So this is also valid. We call this a principle of conditioning. So